everyone. Tonight we're going to learn about relative frequency. And this topic's kind of interesting because it finds itself in the probability category as well as a little bit of statistics. So we're starting to shift towards the second half of some of our units, but you're going to see a blend throughout. Okay, if you go ahead and flip to the next page, we will get started. Okay. Relative frequency is how often or how frequently something happens divided by the total outcomes. Okay, divided by all of the possible outcomes. Okay, so the first example here, okay, it says using relative frequency as a fraction. Okay, the table shows the relative frequency of men, women, and children at a park on a particular day. On that day, 600 people were at the park. Okay, so if we go back to our definition, okay, that's your total number of outcomes, or your total people. Okay, now if we go to the chart, okay, for men, our relative frequency is 0.54, for women, 0.37, and children, 0.09. Okay? And if you add all of these up, you should get one whole population. Okay, all of those frequencies should make up your total people. Okay, and that's what we have over here. Okay, so the first question asks how many children were at the park? Okay, well, if I take the relative frequency for children, 0.09, okay, we want to ask ourselves, how do you pronounce that the proper way? Okay, we know this to be 9/100ths, so we can turn this into a fraction out of 100. Okay, to figure out how many children there were out of our total of 600, we will use a proportion. Aren't you excited? Proportions are back. 9/100 equals x over 600. Okay, so we have our frequency, we have our total population, and now we can solve. Okay, feel free to cross multiply, or we can use a scale factor. Okay, 100 times 6 equals 600. So if I do 9 times 6, I'll be able to solve for x. Okay, and we will get that x equals 54. So we know there were 54 children at the park. Feel free to pause, rewind, and rewatch as you go. We're going to try part B. This question asks, how many more men than women were at the park? Okay, so we'll go back up to our chart and we will pull the frequencies for men and women. Okay, so we have for men 0.54, okay, which is 54/100ths. And we can set that equal to x over 600. Okay. When we cross multiply, 100x equals 54 times 600. Okay, divide both sides by 100. X should equal 324 men. Okay, now we can calculate women, which had a relative frequency of 0.37, or 37/100ths equals x out of our total of 600. I'll use our scale factor again this time, so easy. Okay, when we multiply 37 by 6, we get that x equals 222 women. Okay, now you have to be careful. You have to go back and reread the question. Okay, they wanted to know how many more men than women were at the park. So our final step here is to subtract. 324 men minus 222 women equals 102 more men than women. Feel free to pause, and when you're all set, flip to the next page. We'll do one more example together. On this page, our example says, the table shows the relative frequencies for 3 sizes of monitors sold during a sale at a computer store. 640 monitors were sold during the sale. Okay, so there's your total. Okay, and we have our relative frequencies for 14-inch monitors, 15-inch, and 17-inch. Okay, so the first question is how many 17-inch monitors were sold during the sale? Okay, well, 17-inch monitors has a relative frequency of 0.30 or 30 hundredths. Okay, equals, x over 640, because that's the total. Okay, when we cross multiply, 100 times x is 100x. Okay, and then we have 30 times 640, 19,200. Divide both sides by 100, and x equals 192 17-inch monitors. Okay, now if the question doesn't specify that you should use a fraction, we can actually take that relative frequency and multiply it by our total, and that will also give you the value you're looking for. Okay, just like we learned in our last unit, okay, you can write a fraction as a decimal and as a percent, and they're all equivalent. So you can use multiple methods for finding that value. Okay, then part B says how many fewer 14-inch monitors were sold than 15-inch monitors. Okay, this should be familiar to us from the last page. Okay, so we have 14-inch monitors has a relative frequency of 0.15, so it's 15 hundredths equals x over 640. And when we solve, we should get x equals 96. We can do the same for our 15-inch, which has a relative frequency of 55 hundredths equals x over 640. X equals 352. Okay, and then our final step is to subtract. Okay, 256 fewer 14-inch than 15-inch. Alrighty, if you flip to the next page, okay, this one's just slightly different, but I think you can handle it. Okay, give that one a go. We'll check it tomorrow. We can talk about the answer key. When you're done with that page, flip to our final example. Okay, relative frequency in a histogram. Okay, this is a way of representing statistical data. Okay, so pulling in that statistics. Okay, but it really tells us a lot about our relative frequency as well. Okay, so let's look at this. It says at some schools, a grade point average, GPA, is used to describe academic progress. The histogram shows data about the GPAs of 400 students at the school. Okay, so again, that's your total population, okay, and that's what they're using. So part A says, what is the relative frequency of students whose GPA is at least 3? Okay, then we know that means 3 or higher. Okay, so we're looking at these. Okay, now when I look at this graph, okay, you see this break. That just tells us that we're skipping from 0 to 2, so we don't waste any space. And now we can read these different ranges. 2 to 2.5, 2.5 to 3, 3 to 3.5, 3.5 to 4. Okay, so those that are 3 or higher, okay, well that's 80 and 32. So we can add 80 plus 32, that equals 112. So we have 112 out of our total 400. That equals 7 over 25, or 0.28. And then if they ask you to represent that as a percent, we know that would just be 28%. Okay, part B says, find the relative frequency of students whose GPA is greater than or equal to 3 but less than 5. Okay, so we're in that 3 to 3.5 range, and we want to give your answer as a percent. Okay, so if I look at that range, we're looking right here. We have 80 over 400 equals 1/5, which equals 0.2, which equals 20% when we swoop that decimal over. Okay, so that was our range from 3 to 3.5. Okay, and now they want us to create a histogram using percents. Okay, so the one up top just had number of students, but now we want the relative frequency given in percents. Okay, so we need to figure out that range from 2 to 2.5. Okay, 2.5 to 3. We already have 3 to 3.5 here. Okay, and then we need 3.5 to 4. Okay, so for this, okay, if we look up at our histogram, 2 to 2.5 was 128 over 400, which equals 0.3125, which is about 32% when we bring that over. Okay, the next range should be 160 over 400, which equals 0.4, which equals 40%. And then lastly, for this, we should have 32 over 400, which equals 0.08, which is 8%. Okay. Now that we have that, we can graph. Okay, we can plot our data. So from 2 to 2.5, we are up at 32. Okay, so we can make a bar. Then from 2.5 to 3, we are up at 40. Okay, and the unique thing about a histogram is the bars always touch, and we'll talk about this a lot more in the coming weeks. 3 to 3.5, okay, that should be your 20. And then 3.5 to 4 should be 8%. Okay, so again, 8, 20, 40, 32. And that's how it's done. You have one more practice problem. Okay, so that's 2 practice problems total that I'll be checking tomorrow. Have a good night.